everyone. So in this video, I'm going to go over problems that are similar to what's in your 3.07 TGA. So here you can see we have a system of inequalities on the graph, and then it gives you the inequalities right here. So what it wants us to do is we can use this graph to figure out whether these points are solutions to our inequalities. So you can use the graph I have pictured here, or the reason I gave you the inequalities like written out is because I know some of you prefer to use Desmos. And so if you want to use Desmos, you can use the link that I have in the assignment, or you can just type in the inequalities. Okay, so I'm just going to go ahead and type them in because sometimes it is easier to see if a point is a solution just by typing it into Desmos. So you can see here now I've typed in all the inequalities. You can see this triangular region right here is going to be the solution set. So what you can do if you want to check if a point is a solution, like you can type it in and see where it falls on your graph right here. Okay, so I just wanted to show you, you have the option to use Desmos if you prefer to do that. I'm going to go ahead and use the graph that's pictured here to do this. So the idea here is, remember, if it's on the dotted line, you see how A is on the dotted line? That means it's not included, okay? Because anything that's within this region, our feasible region right here, this shaded region right here, or anything that's on a solid line is what's going to be included. If it's on a dotted line, it's actually not going to be included. So 0, 5 is actually going to be not a solution to the system. If we look at 0, 3, you can see point B is well within our feasible region, so that will be a solution. Okay, and then 3, 4, you can see that's on a solid line. Okay, so solid line means that point is included, so 3, 4 will be a solution also. 5, 5 is like way over here outside our feasible region, so the point D is going to be not a solution to the system. Okay, so now here it says using the grid provided, please sketch a graph of the following system. So you won't receive credit. So what I mean is like if you just go to Desmos and you screenshot and paste, you're not going to get credit for this, okay? But you can use Desmos to help you, okay? So I am fully expecting that you all will use Desmos to help you on this. And what I mean by that is like it gives you an idea of what the graph is supposed to look like. So for example, we have y less than 2x plus 1, right? So that means that I have a dotted line. And remember, to graph 2x plus 1, I put my first point at 1, and then I do slope, I do up 2 over 1, right? And so you can see the boundary line is going to be a dotted line. I can use that to connect these points, and then I just kind of lightly shade the region below, right? We just lightly shade until we get all three inequalities all together. Then we have going to graph y is greater than or equal to -1. So that is going to be actually one of our special lines. So we have y is greater than or equal to, and then we have -1. So greater than or equal to means we have a solid line. So we're going to do a solid line through -1, and then we're going to shade lightly above that. So you can start to see the region of overlap is going to be like over here. But let's also do our x is less than or equal to 2, which is another special line. Okay, so we're going to go to 2 and put a solid line here. And sorry, my line is a little off, but you can see the region where all the shading overlaps is like right here. So I'm going to shade that more darkly. Okay, that's my solution to the system of inequalities. So that's exactly what I want you to do on this. Okay, so you can use Desmos to help, but I don't want any screenshots from Desmos. Okay, I want you to actually sketch it on the grid, or if you're doing it on paper, you can draw yourself a little grid and then sketch the graph. So now let's try this problem. So it gives us the graphed system of inequalities, and now we need to write the system of inequalities represented by this graph. So the thing you really need to remember here is slope-intercept form, y equals mx plus b. Remember that m is the slope and b is the y-intercept. Also remember for our special lines, our horizontal and vertical lines, remember that they have special equations. If it's horizontal, it's going to be a y equals equation. And if it's vertical, it's going to be an x equals equation. So let's go ahead and identify our lines. I'm just going to call this A, call this B, and call this C. It doesn't really matter which order you do them. So let's look at line A. Okay, so A is not a horizontal or vertical line. It's going to do y equals mx plus b, right? So our B, our y-intercept is 3. So I'm going to go ahead and plug that in for B. And then let's look at the slope. So I'm going to pick another point. And if we go left to right, remember we're going up 2, and then we go over 1. Okay, so that slope is going to be 2 over 1, which is equal to 2. So we have y equals 2x plus 3 basically as our equation. But remember, this is not an equation, this is an inequality. So we need to basically figure out the inequality sign that's going to replace that equals sign. So the way to do this is to pick a point that's in your shaded region, okay? And once you pick a point, you're going to use that for every single inequality. So I like to pick ones that have at least one coordinate of 0. Like you don't have to do that, but I just like to. So I'm just going to use the point -4, 0, and that's going to be my test point because that is within my feasible region. So remember, that means my x is -4, y is 0. Okay, if I plug that in here, I get 0 and then something, 2 times -4 plus 3. So I have 0 and then something, and then I have -8 plus 3, and then I have 0, something, and then -5. Okay, so what's the relationship between 0 and -5? Well, 0 is greater than -5, right? And then if we look at that line, notice it's a dotted line. Okay, so I'm just going to leave that as a greater than. So this is going to be y is greater than 2x plus 3. Okay, remember the dotted or solid tells you whether you have a greater than or a greater than or equal to. Okay, now let's look at line B. So B is a vertical line, right? A vertical line is going to have an x equals equation. And so that goes x equals, and let's see, it's x equals -5, right? Because it passes through -5. So remember, we don't have an equation though, we have an inequality. So let's think about what -5 is going to do compared to our test point. So our test point had an x coordinate of -4. So we have -4 and then something -5. -4 is to the right of -5 on the number line. You can see here. So that means it's going to be greater than. Also, this line is solid, so that's going to be a greater than or equal to. So we have -4 greater than or equal to -5. That means x is greater than or equal to -5. Now let's try C. So on C, that's this line going straight across, right? That's my horizontal line. And it's a horizontal line, and you can't see because I drew on here. But if I just kind of delete that, you can see it's y equals 4. Okay, so y equals 4 is going to be that equation. But if I look at that test point, it's going to be like 0 and then something 4, right? 0 is less than 4. And notice this is a solid line once again. So that's going to be 0 less than or equal to 4. So this is going to be y less than or equal to 4. So now I'm just going to gather up all my inequalities and write them all together. So we have x greater than or equal to -5, and then we have y less than or equal to 4. Okay, so this right here is the system of inequalities that's graphed right here. And if you want to check, you can actually go ahead and type these into Desmos and see that it does in fact create this exact same graph. All right, so that's all the examples. If you have any questions on this TGA, please let me know.